In this lesson, we are going to review factoring quadratics. And so quadratics are expressions that have an x squared term. The standard form is ax squared plus bx plus c. When we factor quadratics, we're trying to factor them to two linear factors that just have an x times an x and then maybe a coefficient. Okay? And so those are linear when they don't have an exponent. Technically, the exponent is 1. Okay, and so there's different cases. One case is where you just have what's called a GCF, a greatest common factor. So for example, 3x squared plus 2x, we can factor out an x. Factoring out an x is the same thing as undistributing. If I were to distribute this x back in, I would get the 3x squared plus 2x back. And so when you distribute, you multiply. When you factor, you're dividing it out. Okay, and so if you see a factor in common like this x, you can divide both terms by that x, and then you would just write the x out front. The other case you may remember from Algebra 1 is difference of squares. If these two expressions are perfect, or these two terms are perfect squares, you just square root both of them, and they appear in both factors. One gets a minus, one gets a plus, because when you multiply them back together, it's going to give you that minus sign. It's important that you recognize that it's subtraction. If this were a plus sign, you wouldn't be able to factor it. It would be considered prime. So for example, x squared and 81 are both perfect squares separated by a minus sign. Square root of x squared is x, square root of 81 is 9. So we see the x and we see the 9. One gets a minus, one gets a plus. Okay, when we are factoring when a equals 1, you can guess and check fairly easily. You're basically looking for two numbers that multiply to this constant term c, but add to the middle number b. And so, for example, I would need two numbers that multiply to negative 15, but add to the center number 2. And so those numbers are 5 and negative 3. And so you would just put x plus 5 as one of your factors and negative 3 as the other. In the next example, we're looking for two numbers that multiply to negative 8, but add to 2. And so two numbers that multiply to negative 8, but add to 2 would be 4 and negative 2. And so you see the 4 here, negative 2 here. The order doesn't matter. And so I call those the magic numbers, and I kind of just use this x to organize my information and have something to look at. When a isn't 1, it's a little bit harder because this top number of the x is going to be a times c. Technically, we were doing that before, but a was 1, so it didn't really affect anything. So a times c would be negative 6, and then we still need them to add to the middle number, which in this case is 1. And so the two magic numbers here would be negative 2 and 3. Those multiply to negative 6, but add to 1. And you have an added step. Instead of just jumping to your factors, you can't say x minus 2, x plus 3 are your factors, because there's no way that's going to multiply back to give you a 2x squared. So what you do with that is you split your middle term. So right now, my middle term is 1x. I'm going to use these magic numbers, negative 2 and 3, to split it up, kind of like uncombining your like terms. We're going in reverse. And then from there, you divide it down the middle and just factor 2 out at a time. And so I don't like these parentheses here because now it looks like you're multiplying them. So don't get in the habit of putting parentheses like that. I almost want to get rid of them. Don't put those parentheses. Okay, and so you're just looking at two terms at a time. That's what we're trying to show you. And so once you look at two terms at a time, you are looking for a GCF from each one. So in this case, a GCF would be 2 and an x. And so the 2x goes here, and then we divide. 2x squared divided by 2x is x. 2x divided by 2x would be 1 with the negative sign. Okay, a GCF for this second set would just be a 3. This one doesn't have an x, so we can't do x. And so the 3 goes here, and when I divide those out, I get x and a -1. What's great about this method is if you've done everything right, your parentheses should match. Here we're seeing an x -1 in both. That's one of your factors. The other factor comes from what is in front of the parentheses in this order. So we have the 2x plus 3 forming the other factors. Okay, so let's just do some examples. I want to start with any kind of GCF problem, which was the first type we looked at, the GCF, greatest common factor. And so number 1 is a GCF problem. And I don't see any others. And so I recognize it because there's an x here and there's only 2 terms. And so I know I can divide both of these by x, and then looking at the numbers, 6 and 24 are both divisible by 6. And so 6x is my GCF, put it outside the parentheses, and then do your division. 6x squared divided by 6x would just be 1x. 24x divided by 6x is 4. And so the factored form of this quadratic is 6x times x plus 4. Next, I'm going to look for some difference of squares. Let's do red for that. Difference of squares. Okay, and so we're looking for 2 terms that are perfect squares. Here, we kind of just saw that one in the example. And then we have another one here, 2 terms that are perfect squares. And so the square root of x squared is x. The square root of 81 is 9. And so in your 2 parentheses, you're going to write the x and the 9 twice. One with the minus, one with the plus, and then you're done. Okay, same idea here. The square root of 9x squared is 3x. The square root of 100 is 10. And so you're going to write the 3x and the 10 twice. One with the minus, one with the plus. It's important that each time you notice there's a minus sign between them. Okay, these are difference of squares. Difference of squares. This was a GCF. Okay, next we're going to look for all the examples where a is 1. And so a is 1 here, a is 1 here. A is always just the leading coefficient. It looks like that's it. Okay, so whenever a is 1, you're looking for 2 numbers that multiply to c, but add to the middle number, which is b. So 2 numbers that multiply to 8 but add to 6 are 2 and 4. And so my factors are x plus 2, x plus 4, either order. And in each case, you could FOIL this back out and see that it gives you this trinomial. You could redistribute the 6x and see that it gives you the original trinomial. You can multiply these out, FOILing it, and then you would see your center term would cancel, giving you x squared minus 81, and so on. Okay, number 4, our a is at 1, but, oh, I skipped 3. So 3, a is still 1, so we just need 2 numbers that multiply to negative 20, but add to negative 8. Okay, and so if you struggle with finding these numbers, list all the numbers that multiply to 20. So 1 and 20, 2 and 10, 4 and 5, and that's it. And so the only promising pair to get to negative 8 is the 2 and the 10. And then we just need to decide which one needs to be negative. Because 8 is negative, the 10 would need to be negative, because 2 plus negative 10 would give you that negative 8. And so one of my factors is x plus 2 because it was positive 2. The other factor is x minus 10. Okay, so looking at number 4, A isn't 1, but always check to see if the other numbers are divisible by that A value. In this case, it is. That means 3 is a numerical GCF for this problem, and so I can factor it out or divide each of these numbers by 3. And then that gives us smaller numbers to work with. Now we're dealing with this quadratic that we've already factored to x plus 2 and x plus 4. The only difference is now you have this GCF to keep for your final answer. That way, when you multiply it all back out, you get the 3x squared plus 18x plus 24. So this one had a GCF. So always look for that right off the bat. Okay, number 5, a similar situation. All of these numbers are divisible by our A value 2. And so we can factor out the 2. And it leaves behind x squared plus 3x plus 2. And so now we have a trinomial that has an A value of 1. We love that. So we need two numbers that multiply to 2, but add to 3. Those numbers are 1 and 2. So one of my factors is x plus 1. The other is x plus 2. And then don't forget this 2 in front. Don't distribute it back, just leave it in front as your final answer. Okay, this next one, 3 does not divide the other numbers evenly, and so we have to factor this one by splitting the middle and factor by grouping. Okay, and so A times C is negative 18. We need two numbers that multiply to negative 18, but add to negative 7. Those numbers are 9 and 2, make the 9 negative. And so you take the negative 9 and 2, and that's what you're splitting the x term with. So instead of writing negative 7x, we're writing minus 9x plus 2x using these magic numbers. And then you just bring down the last term, bring down the first term, and we're going to factor 2 at a time. So my first pair, both of those are divisible by 3, and they both have an x. So 3x is my GCF. 3x squared divided by 3x is just x. And then negative 9 divided by 3 is negative 3, and the x's cancel. For my second pair, I can divide both of those by 2. 2x divided by 2 is just x. Negative 6 divided by 2 is negative 3. And so my parentheses match, which means I'm doing everything right so far. The parentheses, that's just one of your factors. So x minus 3 is one of my factors. And then the other factor comes from the 3x and the 2. In that order, 3x and it's positive 2, so plus 2. So this would be our final answer. Okay, 2 more. Here we've got a 5 as an A value, which does not divide 23 or 12, so we're kind of stuck splitting the middle and factor by grouping. So A times C, 5 times 12 is 60, and we need them to add to negative 23. Let's see. 20 and 3 multiply to 60, but in order to add to negative 23, we need them both to be negative. That way they still multiply to the positive, but add to this negative 23. Okay, and so we split up the negative 23 into negative 20x minus 3x. And the order you write this in doesn't matter. You'll just get your factors in a different order, but you'll get the same final answer. Divide it down the middle. I can divide the first pair by 5x, which leaves behind an x minus 4. And then the second pair, if your leader is negative, so is your GCF. That's why I went ahead and wrote the negative. And so we're dividing both of them by a -3, which leaves positive x minus 4. So whenever your leader is negative, so is your GCF. Okay, our parentheses match. That means we did everything right so far. The x minus 4 is one of our factors. The other factor is 5x minus 3. And the 5x minus 3 comes from the outsides in that order. And it's minus 3 this time because the 3 was negative. Okay, last one. We have an a value of 2. 11 is not divisible by 2, so it's not a GCF. So we have to do a times c, which is 24. And then we need numbers that add to 11. And so two numbers that multiply to 24 but add to 11 would be 8 and 3. And so we have 8x and 3x to split the middle term. Bring down your plus 12, bring down your 2x squared. Draw your line. Out of the first pair, we can divide out a 2 and an x, which leaves behind x plus 4. Out of the second pair, we can get a 3 only, because this doesn't have an x, which leaves behind an x and a 4. The x plus 4 is matched. That's one of my factors. And then if those don't match, go find your mistake. The other factor is 2x plus 3, the outsides. And so my final answer is x plus 4 times 2x plus 3.